Welcome to the Phenomenological Alliance channel. In this video, we will delve into the next question that phenomenology raises in the field of natural sciences: the issue of prioritizing less obvious notions over more obvious ones.
After Michael Faraday discovered the phenomenon of electromagnetic induction in 1831, the understanding of electromagnetic phenomena underwent accelerated development. Some of the important properties of electricity are: electrostatic force refers to the phenomenon of attractive or repulsive forces between electrified bodies. Electromagnetic induction is the phenomenon involving the creation of a magnetic field around a moving electrical conductor, and conversely, the generation of electricity by moving an electric conductor in a magnetic field. The skin effect refers to the tendency of an alternating electric current to distribute itself differently within a conductor based on its frequency. Electrical grounding, or earthing, is the phenomenon of discharging electrified bodies upon physical contact with the earth. Electrostatic shielding is the phenomenon where objects can be protected from electromagnetic radiation with the help of a closed metal object. On the other hand, in the second half of the 19th century, there was a strong tendency to unify all forces in nature through the concept of a single force. In such a state of mind, Maxwell proposed the theory that light is of electromagnetic nature in 1861. Through calculations, Maxwell demonstrated that the speed of light correlates to the dielectric constant, which determines the electric and magnetic properties of the medium through which an electromagnetic wave propagates. Maxwell's theory was confirmed when it was discovered that electromagnetic waves can produce an effect on light. For example, a dielectric material changes its refractive index in an electric field. Or, a strong magnetic field rotates a plane of polarized light. Thus, the scientific community accepted the stance that light is of electromagnetic nature.
Let's take a closer look at the stated positions. Later, it turned out that the Maxwell formula is not correct, because there are many materials in which the square root of the dielectric constant is not related to the index of refraction. Moreover, the evidence supporting the electromagnetic nature of light is logically weak. Based on the fact that one thing affects another, one cannot consider as an irrefutable truth that these things are of the same nature. A magnet is not of the same nature as iron, just because a magnet produces effect on iron. Examination of the properties of light and electromagnetism indicates that these two phenomena have completely different characteristics. For a long time, it was considered that the radiometer demonstrates the effect of light in terms of force. Subsequently, it was realized that the rotor spins according to the blackened side of the blades. In fact, temperature differences and not light drive the blades of the radiometer. There is no electromagnetic induction in the field of luminous phenomena. Sources of light in motion don't produce magnetic field or electrical charging. In luminous phenomena, there is no skin effect. Different frequencies of light, for example, blue and red, do not show the different concentration on the surface of the material. Grounding does not make transparent objects opaque. Most electrical conductors are not transparent, which should not be the case if light is of electromagnetic nature. A Faraday cage does not prevent the penetration of light. With the use of table salt solution, we can create a transparent conductor suitable for constructing a Faraday cage. Place a mobile phone in a sealed glass jar. When the jar is afloat on the solution, a call can be made because the signal can penetrate through the glass. However, if we submerge the jar into the solution, the call cannot be made, even though the mobile phone remains visible. Much like the concept of the attractive force between matter, the concept of the electromagnetic nature of light didn't arise from the direct observation of the phenomena, but rather from a declaration based on a mathematical calculation. Man does not have a sense through which he can directly perceive electromagnetic phenomena. Again, light is perceived through the sense of sight. For those who prioritize common sense over authoritative opinions, this fact presents a compelling argument against the theory of the electromagnetic nature of light, even taking into account the fact that the electromagnetic field can affect the optical properties of materials.
In modern physics, it is often considered that cognition can be reached proceeding from notions about the behavior of particles of microscopic level to understand macroscopic phenomena. Practically, from the less obvious one tries to understand the obvious. Phenomenology examines the structure of consciousness and as a method, proceeds from exactly the opposite principles. Namely, through obvious insights, one tries to understand the less obvious. By dealing with facts, there is no need to be engaged in proving, because facts are proof in themselves.
The phenomenological study of light shows that light has neither electrical nor magnetic properties, which is an obvious fact, not a speculation. The conviction that light is electromagnetic wave is tenable, but only by denying many obvious facts. Yet, for the phenomenological approach, obviousness is the primary source for the formation of attitudes. Since the thesis that light is an electromagnetic wave can be questioned, let's examine whether thermal radiation exhibits electromagnetic properties.